Hello everyone, welcome back to my channel. So today I've come with a new video with the same topic that I've already started previously. As written on the board, it's light. So in my previous video I've already told you about reflection, number of images formed for pair mirrors, and I've also told you about the basics of concave and convex. Today we are going to proceed with further details of concave and convex, and I am going to tell you that the ray diagrams, which is the most important part of this chapter, which is your ray diagrams. So without knowing that, obviously light is nothing. We need to know those two concepts in order to move on with this particular chapter, because it's a very interesting chapter. In the beginning only I've told you one of the easiest chapter. After that comes sound, so let's not go to it. But ray diagrams are important, and there are certain things which we have to remember while doing ray diagrams, the rules. Okay, so first let me tell you about the basics of convex and concave. That means all the parts of convex and concave. If I tell you for the other mirror, all the things will be the same, only side will change. Okay. And another video I'll make after this, which will be based on Cartesian system, which is another interesting topic and which consists of few numericals. Okay, I'll solve few numericals for you after explaining you the formula, but that is to be done in my next video. So I've already told you that there are two spherical mirrors. One is concave, another is convex. Now I've told you a small trick to remember, which is concave and which is convex. Basically, both the structures are same. Both the structures are same. C-shaped. That's why they are spherical, right? But the difference between the two is the reflecting surface. So in case of concave, we will see the term cave. So see, cave means what? We are getting inside the cave. So light rays are getting inside the cave, assuming this to be a cave. So light rays getting inside the cave. So the reflecting surface is this. So this one will be the silver portion or the coated portion, and opposite will be for convex. So for convex it will be this side of the mirror. Okay. Now there are few terms which are related to this two mirrors. So let me tell you for concave at first, and then I'll tell you for convex. Concepts are the same, only side will change. Okay? I tell you, maybe this word side will change. This particular sentence is not clear to you. People who are new to this topic, they will be in confusion. But don't worry, I'll tell you. First of all, let's draw one concave mirror. This is the concave mirror. Now, assume that there was a circle. There was a circle, out of which we have cut one portion, removed this particular thing, and we have taken this thing from a circle. Okay? And what we did is, we did a silver coating on this side. So this side became a shiny portion. That's what we have taken here. Okay? Forget about that. Now think, or go to the past, when it was a circle. When it was a circle. Circle has a geometrical center. What is it called? Center. Right? So, if this was also a circle, means earlier this was also a circle, right? So, it also had a center. It also had a center. So, this will be the center, right? Just assuming, I don't know what's the radius and diameter. Just assuming that this is the center. This was the center. So for the spherical mirror also, as it is a part of the circle, we can also, means for the circle if we can denote the center, then for the spherical mirror also we can denote the center. And this is called the center of curvature. This is called the center of curvature. Let's name it. Name it as O. Done. Now, for the circle we have one, longest chord. What is that? Diameter. One characteristic property of diameter, it will always touch the center. So for spherical mirror also diameter will be there. So let's draw the diameter. Now here it was called Means this particular line was called diameter. Here we will not call it diameter. We don't have the right to call it diameter because it has got its a separate name. What is that name? Principal axis. So if I am going according to the text which is written in my book, then where did it go? Yes. It is the straight line joining the pole of the mirror to its center of curvature. What is the pole of the mirror? Coming to it. So O was my center of curvature. Center of curvature. Suppose it's A and A dash. Means this particular point is A dash. This particular point is A dash. So A dash, this particular line was line segment also we can say because it started from a point. So this is your principal axis. And this particular point on the spherical mirror, that particular point, what is that particular point called? A dash. Here I have named as A dash. It can be A, B, B, B dash, anything. Here I am telling it as A dash or A prime, whatever you say. So this particular point which lies on the center of curvature, let me read the book. The geometric center of the spherical surface of mirror. Obviously it's the center of the spherical surface. That is according to the text I am explaining in my own words. So this particular point is called the pole. So A dash is your pole. Now the previous definition which I said for principal axis. It is proved that it's a line which is joining the center of curvature and the pole. Simple. After that, we have radius of curvature. Now, if this is your center, then what is radius? Here to here, sorry. Here to here, this is your radius. Let's name it as suppose A dash. Because here we have named as A dash, so I am taking it as A dash only. This is your radius, this particular portion, isn't it? So here also O A dash will be what? Radius of curvature. Simple. Okay. After that, we have only one more thing left. Then we will directly dive into the ray diagram. Aperture. Aperture is a very simple thing. Let me read it out. The plane surface area of the mirror through which light rays enter and fall on the mirror is called its aperture. Repeating the statement again. The plane surface area of the mirror. The plane surface area of the mirror is related to my diagram. Through which light rays enter. And fall on the mirror. Obviously, light rays entering and falling on the mirror on this particular area, that is a plane surface, the reflecting area is called the aperture. Clear? So, this particular portion we were calling it as radius. I did not mark it. This is a radius. Okay? Now, this was for concave. Coming to convex. So before moving on with convex, same thing. Let me tell you about focus and focal length a bit. Basically, there is a rule. Okay, I've already said in the beginning that we have to know few rules for drawing the ray diagrams. Amongst those 4 rules, the first rule is the light rays. I'm telling it now, otherwise I'll not be able to explain you focus. Okay, so I'm telling you the rule at first. Only one rule I'll tell now, then I'll move on with convex, and then other 3 rules I'll tell. So, light rays which are parallel to principal axis, see, it's parallel to principal axis. Which is the principal axis? This is the principal axis, see, parallel to principal axis, right? So light rays which are parallel to principal axis after reflection, this is the reflecting surface, after reflection they converge for concave mirror. they converge and meet at a particular point. Naming it as F. Obviously, many of you have got the clue from this particular point, which I've called it F. Many of you have got the clue. Those are new to this chapter, obviously they will get the clue rather. Means those who already know the chapter, for them it's easy, very much easy. So for the so light rays which are parallel to the principal axis, they will obviously converge after reflection, as our rule says. And they will meet at a particular point which we are calling it as F. Now why did I call it F? Because that is my focus. That is my focus or principal focus. So F is my principal focus. And focus is always somewhere between O and A dash. O and A dash. Somewhere in the middle. Always. It will be in the center of this particular line. And suppose if it is F, the distance between F and A dash is called small f. What is small f? Focal length. From here we have one formula also. That is R equals to 2f. How did this formula come? Basically, I've said that. So if I'm telling you how did this formula come. Very simple. Before that, let me just check once that what are the things that I need to cover for today, so that I'll speed up accordingly. Okay. So I need to cover many things today. Let's speed up. How did this formula come? Basically, I said that in other way we can say half equals to 1 by 2r also. Same thing. I just cross multiplied it. How did this come? If this is your line O and A dash, then what is it called? R? Or what is it called? Means what is it named as? R, that is the radius. And I said that focus will be a point which will always be at the center of the radius. That means what? It will divide radius into two equal halves. That is O and A is getting divided into two equal halves due to F. And F A dash, that is called your focal length. So if this is F, then OF will also be focal length. Don't be confused. If this particular length is called a focal length, then this will also be called a focal length. Small f. Why? Because I said R, that is the radius, is getting divided into two equal halves by focus. But we will not call it focal length. Because conceptually, this is your focal length. That is, the line or the distance between principal focus and the pole is called a focal length. That what our definition says, or that what our text of the book says. But according to mathematics, if we go, then this line can also be called as focal length. So can we say this full R equals to 2f? So that's what I have written here. Proved. This is the formula, very important formula. Now coming to the convex mirror. I've already told you about concave. Very simple, and the same thing is gonna be repeated here. So for concave, everything was this side, right? For convex, things will go that side. That means what? It is going to be changed. So let's draw one more this thing. Sorry. So what is this line called? Principal axis, as I've already said earlier. And this point will be called your A dash. This is your pole. right? Here I have taken one center of curvature, naming it as C, which are named here as O, so let it be O only. And focus, F is the point which will lie in the middle. Focus, this full line was called the radius. This particular line is called the focal length. Again proving it, or again proving, not again writing the formula, that is R equals to 2F, implies that F equals to half R. Okay. So I've said the principal axis, so center of curvature, principal axis, pole, radius, focal length. So everything I've covered. And what is happening for convex mirror when things are parallel or light rays are parallel to principal axis? Then we can draw it like this. Hope it's visible. Now for convex mirror, the light rays appear to converge, but actually they diverge. So they will appear that it is coming from the point called the focus, but actually it will diverge like this, maintaining laws of reflection. Like here actually light rays were meeting. Actually light rays were meeting in case of concave. But in case of convex, light rays are not actually meeting. Rather, they are getting diverged. But the observer will feel like the light rays are meeting somewhere behind the mirror. Somewhere behind the mirror, virtual. And it will appear that it is coming from a particular point, which in case of convex, obviously it will be called the focus. Okay. Now coming to the 4 rules. The first rule I have already said. Light rays parallel to principal axis always converge in case of concave and meet at the focus, and in case of convex they will diverge, but it will appear that it is coming from the focus. So coming to number 1 rule, a light ray passing through center of curvature. Number 2, light ray passing through center of curvature. Very simple. Suppose this is your center of curvature. So light rays which is passing through center of curvature, like this it will pass. Here lines will not be straight because I am drawing freehand. But in case of exam or while you practice, it should be done with ruler and a pencil, not with pen. Okay? And giving arrows, mandatory, without which school will not give you marks. Will not give you a single marks without arrow. Because simply if I draw, then actually when you are writing the answer script, at that point of time, you are the teacher and the student, you are the teacher and your teacher is a student. Okay, you are explaining with your teacher the answer. So you are the teacher. So if you are not applying the arrows in case of the light rays, then how will the teacher or any person who reads your answer script will understand from where did the light enter and from where did the light go? So you need to make the person understand. So for that, arrows to be given on mandatory basis. Done? So in case of concave, the second rule says that if a light is passing through center of curvature, that is C, then according to the second rule, it will not diverge or converge, it will do nothing. Straight away retrace the path or straight away move through the same path. So light rays entered like this, light rays went like this, following the same path. No change. This is your second rule. Now what in case of convex? In case of convex, what will happen? This is your C. Light rays will appear as if they are meeting center of curvature according to the observer. Okay, it will appear that it is meeting the center of curvature. But actually it will not. And what will happen? Here also it will retrace the path or follow the same path. So it will move through the same particular path. Okay. So here actually the point is touching C. But here it's not actually touching or meeting at C. But it will feel like it is touching the point C. That is the center of curvature. The third law states that, or what's the third condition also you can say, a ray passing through the focus or the principal focus. Now suppose a light ray is passing through the principal focus. Just the reverse. If light ray is parallel to principal axis, it will pass through focus. If light ray passes through focus, then what will it do? It will be parallel to principal axis, just the reverse. So, concave mirror, principal axis, focus, light ray passing through focus will become parallel to principal axis. Now in case of drawing the ray diagrams, the thing may change also. That is, it can become like this. Here light ray entered like this. And according to the question paper or according to many ray diagrams, light ray will enter like this. Through focus only. So again it will become parallel to principal axis. And what in case of convex? It will appear as if it is coming and meeting the focus, and it will be parallel to the principal axis. Okay? Next you have our light ray incidenting at the pole. The fourth condition. So in case of concave, this is your pole. Light ray incidenting at the pole, it will just deflect following laws of reflection. And suppose if this is your normal, then this is the angle of incidence, this is the angle of reflection. So angle I will be equals to angle R. Okay. And what in case of convex? It will not go to that side of the mirror only. This is the pole, incidenting on the pole, reflecting by following the laws of reflection. Like this. Okay? Coming to the ray diagrams. Again saying, here the lines which I am drawing are not straight. Okay? Sometimes they are getting bent or crooked, but in case of exam or when you are practicing, it should be done using a pencil and a ruler, and arrows to be given on mandatory basis. Okay? So next you have ray diagrams for formation of images in a concave mirror. So total you have 6. For convex there is a ray diagram, but I am not going to tell you that because it's not so important and I don't want to give extra time for that. So 6 diagrams of concave I will show you for today. Number 1 says, at first let me tell you how many position of object will be there. Obviously if you don't keep an object, image will not be formed. For here what will be our object? It will be an arrow. This is going to be our object. What are the 6 positions in which 6 different kinds of images we are going to get, or 6 different position of image we are going to get? So number one is, at first you have to draw everything. Pole, focus, center of curvature. First object can be kept at infinity. Somewhere outside. Okay? Somewhere outside, not here in the scenario. At infinity. Next, I'm going according to the order given in my textbook. When the object is kept at a far distance, it's almost the same. Okay? So let's not differentiate it into two different concepts. It's almost the same. So knowing one will help you. Next you have when object is beyond center of curvature. So number one is at infinity, outside of the scenario. Number two is when it is kept beyond center of curvature. Number three is at center of curvature. Number four, between center of curvature and focus. Number five, at focus. Number six, between focus and the pole. So these are the 6 positions where you can keep your objects and see where the images are forming. Okay? One by one, let me tell you. So number one, now here I am drawing by using a different, means I am drawing it in my own way. Using the rules, you can draw in different ways also. Suppose in case of my ray diagram, I can pass, or I can make a light ray pass like this through focus. In your diagram, you can make it pass like this. Okay? But always confirm by a teacher or anyone that what concept you are applying is correct. Because here, according to the rules, things will be correct. Many ray diagrams, according to the rules, your diagram or your concept will be correct. But in practical life, it may not take place. Okay? So if it happens, then you should always take a confirmation from a teacher or any kind of other source. Okay? So here I am drawing according to the ray diagram which is taught to me and by seeing the book. Using those two concepts, I am going to draw the ray diagrams for you. So firstly, you have when the object is kept at infinity. So if an object is kept at infinity, light rays can come in this way also, right rays can come in this way also. In concise, you will have these two diagrams are given different names, as I've already said, far distance, infinity. But you can apply it for the same concept also. That is, you can remember in one particular heading also. Okay? So I'm showing you one which is parallel to the principal axis. Easier for you to understand. And characteristics of the image I'll tell, but I'll not write since it will take lots and lots of time. So light rays parallel to the principal axis obviously will converge at the focus. Right? So when the object is kept at infinity, then the image is in the focal length of the mirror. It is real. Okay. Sorry. When the object is kept at infinity, the image is at the focus. It is real, it is inverted, and it is diminished to a point. Diminished to a point means the size is decreased to a point. It is inverted and it is real. What is real and virtual image? Real image which is formed in front of the mirror, virtual image is formed behind the mirror. In case of real image, light rays actually meet, and in case of virtual image, light rays does not meet in actual, but they appear to meet. Okay? And what we know about inverted? Obviously, this is an erect one. This is inverted. Real images are always inverted, real images. And virtual images are always erect. Okay? Now, this is when the object is kept at infinity. Now, coming to when the object is kept beyond center of curvature. Before moving on with that, let me tell you a small thing. I have said that you can obviously ray diagrams are not same for both the headings. That is when the object is kept at infinity and when it is kept at far distance. Because when you are keeping it at far distance, then it is highly diminished, means the image is highly diminished, the image will be formed like this. This is the focus, then the image will be like this. So it's not like it is diminished to a point. It is highly diminished. But it is not diminished to a point as it is in case of when the object is kept at infinity. Okay, so I'm not drawing it. Concept is same. Just when you will draw it properly, you will find that it is getting highly diminished but not diminished to a point. Done? But I'm not telling it since remembering one will work. Okay, but in exam maybe in your question paper you will find that two different questions are being formed from these two different things. So apply your concept, the same concept, and accordingly you will form your own ray diagram. When the object is kept beyond the center of curvature. So if I am keeping beyond the center of curvature, okay, let me draw it that side. Wait, it will be easier for me. Let me draw it at first, then I am explaining. So when the object is kept at center of curvature, sorry, it was beyond center of curvature. I've drawn it at center of curvature, whatever. It's just the sequence is changed. So at first let me tell you when the object is kept at center of curvature, then I'll say when the object is kept beyond center of curvature. So when the object is kept at center of curvature, then at that point of time we will see that the light rays are at first parallel to the principal axis, then it is passing through focus, and another light ray will be passing through focus and be parallel to the principal axis. And it will be formed at center of curvature only. The size of the image will be same, no change in the size, but it will be dual and inverted. Next, when it is kept beyond center of curvature, decrease the size of it. So another one is when the object is kept beyond center of curvature. So one is parallel to the principal axis and another is passing through center of curvature. One which is passing through center of curvature will retrace the path. Another which is parallel to the focus will pass, parallel to the principal axis will pass through focus, right? So when they are meeting, when the light rays are meeting, then only the image will be formed. Where they are meeting between focus and center of curvature. See here, they are meeting here. That is between focus and center of curvature. Okay. Maybe here you can, see a mess because I'm drawing with a marker, not with a sharpened pencil. That's why it is getting messed up here. But actually, ray diagrams are not, to be drawn with a very blunt pencil or something. It should be done with a sharpened pencil. Okay, to make your diagram look clean. Next is when your object is placed between center of curvature and focus. Now here there is a twist because here things were getting diminished. Now here you will see things or the image size is getting magnified or enlarged. This was your pole, center of curvature, focus. So here basically one is parallel to the principal axis, another is passing through your focus. That concept only we are going to use or apply. So see, object is kept between center of curvature and focus, and the object is obtained beyond C, right? So one is parallel to principal axis, passing through focus. Another is passing through focus, parallel to principal axis. Characteristic features: one is inverted, enlarged or magnified, and formed between C and F. Next, when the object is kept at focus. Okay, when the object is kept at focus, then again there is a twist. We will not have the image only. It will be formed at infinity. Let's see how. So see, light rays are going to meet in infinity. So we will not be drawing the image. So one is parallel to principal axis, passing through focus. Another is passing through center of curvature and retracing the path. What are the characteristic image? Highly magnified. Obviously, if it is meeting at infinity, then the image will be highly magnified, real and inverted. And the last ray diagram for today is when it is placed between F and P. Again, there is a twist. Let me draw it, then I'll tell you. So here what is going to happen is the object is kept between F and P, right? So one ray is going to pass through center of curvature, but it will appear that it is going beyond the mirror. And another will be parallel to the principal axis, very small I have drawn here. Okay, maybe it's a mess here since I have said already I am drawing with a marker. And it will be parallel to principal axis and passing through focus. But it will be like, or it will feel like it is going beyond the mirror. So these two light rays will meet and form the image behind the mirror. And this is going to be a virtual and erect image. Okay? And this is also going to be enlarged or magnified. So this was all for today. Hope you have liked my video. Please like, share and subscribe it. Also press the bell icon for getting the updates of my uploaded video. So in my next part 3, which is going to be, I'll come up with my Cartesian system, the last topic of the chapter, then move on with some new interesting topic and proceed with the practical video, okay, of this chapter light. So till then, bye.